Yo, what's up, pre-calculus? This is Mr. Taryn rocking with you today. Just want to give you a quick example on how to do continuity tests. So I'm going to zip through a lot of this PowerPoint very quickly, but I am going to do an example of continuity test on here, which should be good for you to see. Just going to scoot by here. End behavior you did yesterday. We're going to stat. If you need any help, anything on end behavior, give me an email and we can take care of that. So first off, some vocab. A continuous function means there's no breaks, no vertical asymptotes, no holes, no gaps. A discontinuous function is a function that is not continuous, so it has a break or a hole or that. Here are the different types of discontinuity. We have infinite discontinuity. That is when you have a vertical asymptote. We have jump discontinuity. That is when we have a piecewise function, so there's a jump. And then we have removable discontinuity, which means there's a little hole in there where we have, if we were to put in an x value, we would get an undefined y value. I'm not going to spend too much time on that, though. Go ahead and keep moving on. I really want to get to a continuity test type question without making this video too long. Here are the 3 steps of continuity tests, though. Number 1, you need to plug in and see, well, at a specific x value, does the function exist? Okay, that means, is it defined, is it undefined? Next, your second step is after you define, or after you see if it exists or not, you are going to create a table and to see where the limit approaches, and then last, you're gonna create, or you're gonna write a limit statement, and then you're gonna use that information to draw a conclusion. Okay, so here we go. First example, I'm gonna zoom this way down here so we have lots of room. Okay, so here we go. F of x, let's see, do green. F of x is equal to 1 over 2x plus 1. And then at x equals 1/2, that's what we're testing. So the first thing I want to do, step 1, is I want to see if this exists. So what I'm going to do is I'm going to plug in this x equals 1/2 here into my x value. So I have 1 over 2, and this is that 1/2 that we plugged in there. So that's going to equal 1 over 2 times 1/2 is 1 plus 1 is 2. So yeah, it does exist. What that means is, yeah, if I plug in an x value of 1/2, I will get a y value of 1/2. So that means it exists. It's not undefined. So now our next step is we need to create a table. And when we create our table, we want to use this number here in the middle, so 0.5. And we got an answer that was 0.5, right? This is x, this is f of x. Now, I want to see what happens as we get really, really, really close to 0.5 on both sides. So something like this, 0.5001, 0.501, and 0.51. As you can see, as we converge to 0.5, we're getting infinitely close to 0.5, but we're not actually going to touch 0.5. Then we're going to do the same thing on the other side. So 0.4999, I believe, 0.499, and 0.49. As you can see, we're getting very, very close to 0.5. Now what you want to do is you want to put this function into your calculator. You want to go to your y equals. I'm actually going to do that right now. You're going to go into your y equals, and you're going to put that into your calculator. Once you have that in there, what you're going to want to do is you're going to want to go to second. I'll even write this down. You're going to want to go to second window. And you want to change your independent variable to ask. Once you do that, you can quit out of that, now you can go to second graph, and it will give you a table. So what you're going to do here is when you have your table, you're going to be entering those numbers. So when I enter, let me just enter this into my y equals here real quick. 1 over 2x plus 1. So if I enter a x value of 0.49, I'm getting 0.50505 for my y value. If I enter 0.499, I'm getting 0.5005. If I enter 0.4999, I'm getting 0.50005. So what it looks like what's happening is as we're converging closer to 0.5 from the left side, it looks like it's approaching 0.5. If you put it all in the calculator same way, you're going to get something that looks like more or less something that looks like this. Might not be exact, but when you do your calculator, it should look like that. I'm just copying these down off the PowerPoint because I don't have time to do it on my calculator. So this is the important part. This is the part where you're going to have to do some thinking. What's going on here? Well, it looks like as my function approaches 0.5 from the left, it looks like it's approaching that point. It looks like it's approaching that coordinate 0.5, 0.5. Same thing over here. So it looks like they're converging on the same point, plus that point exists, so I know my function is continuous. If this was undefined here, then I would have like a removable discontinuity or something like that. It would be a hole. But the last thing we need to do is we just need to write our statements. So I could say something like the limit of f of x as x approaches 1/2 from the left side is equal to 1/2. Also the limit f of x as x approaches 1/2 from the right side, so we're going to use a plus sign here, is also equal to 1/2. So since the limits are approaching the same number and that number exists, we would say it's continuous. And that is an example of continuity test. I know it's pretty confusing. I expect there to be a lot of questions. See if you can get on the live link today, and I will help you out with that. But other than that, good luck, y'all, and have a great rest of your day.